The heat that leaves the block is the same magnitude but opposite in sign to the heat that enters the air. So when we have heat leaving a substance, that's a negative Q, and heat added to a system is positive Q. Since the magnitudes are the same, the heat that leaves the gold is the same as the heat that enters the air. We could say the negative Q of the gold equals the positive Q of the air, and we can sub in for Q. So the MC delta T of the gold equals MC delta T of the air, and we have these quantities for each one. So the mass of gold is 5m times C, 0.129, times the change in temperature, T2 minus T1, T1 is 1050, equals our mass of the air, which was m, times C, times the change in temperature, which is also T2, minus our initial temperature, 25 degrees. So notice that the m's would cancel. We have the same thing on either side, so those would cancel. We basically are dividing both sides by m. T2 is also the same. These won't cancel, but why can we use the same variable, T2, on both sides?
End up at the same temperature.
Yeah. Over a certain amount of time, these substances will reach equilibrium, same temperature, and when the temperature is the same, there's no heat transfer. So T2 is the same. And we'll be solving for T2, final temperature. Rearranging for T2, we can distribute, multiply this in and distribute, giving us collecting like terms and isolating for T2. Now we have, dividing both sides, we have T2 equals 422.07 degrees C. And in Kelvin, this would be equal to 695.07 Kelvin.